Hi and welcome back to section Compatibility and Code Migration to Java SE 9. In the previous section, we have introduced the Java Platform Module System, or JPMS for short, in more details. It's Java 9's most important new core feature, the modularity, the result of Project Jigsaw, which help developers at all levels to be more productive as they build, maintain, and evolve software systems, especially very large and scaled-down systems. Now, let's move on to see what we have to cover during this section. In this section, we are going to take a look at the compatibility and code migration techniques to Java SE 9. First, we will have a deeper look at module dependency graphs and how to avoid module dependency problems that could be raised when implementing modules. Then, we will go through the different techniques available in Java SE 9 to help you migrate your current code base to the new Java SE 9 smoothly. After that, we will deep dive to understand what is the unnamed, root, and automatic modules. And finally, how to use JDEPs. It is the Java Dependency Analysis tool to help you migrate your code to Java 9, which was introduced in Java 8 to help you determine types like class, package, and now module dependencies. Are you ready? I'm eager to this, so let's start. Now, we move on to the first video of this section, more on module dependency graph. Previously, I have showed and explained many different examples about module dependency graph, but in a simple way. Here we will continue our discussion of advanced module graphs and errors that could occur due to incorrect implementation ways of the modules. So, in this video, we are going to take a look at the dependency graph components of a module depending on Java.desktop Java SE module. Get a closer look at the aggregator modules java.se and java.se.ee. Finally, the errors that occur if a module directly or indirectly requires itself. This is known as cycle dependency problems. So, in order to understand the dependency graph, let's first check our simple module depending on Java.desktop module and its component. I have already developed such a module and application, so let's navigate to our exercise files to open our project. From welcome screen of IntelliJ IDEA, I'll click open, go to desktop, open your exercise files, section 2, the first video, then select dependency graph project and click open, and our project will open in our IntelliJ IDE. Now, let's show the module dependency graph for a module named module.graph.test that depends on Java.desktop module as per this declaration. So, module dependency graph, right click on the module, go to the diagram, show diagrams, Java modules diagram, and it will open the module dependency graph for our developed module. Let's make it bigger a little bit, that's fine. Now let's explain the module dependency graph. IntelliJ IDEA shows the module declaration graph for module.graph.test with a box. It also shows Java.desktop module. It's explicitly listed in the required directive. The other modules with the blue lines showing Java.xml and Java data transfer are included in the graph because Java.desktop requires them transitively, while Java.prefs has a direct gray line to indicate it is declared with required directive by Java.desktop. Let's move to get insight on a more complex module dependency graph. Now, let's show the significantly more complex Java.se modules dependency graph. This is an aggregator module. To do this, close this and open external Java SE modules and point to Java.se, right click, diagrams, show diagram, Java modules diagram. Let's make it a little bit bigger, that's fine. So, as we have said, this is an aggregator module that specifies via requires transitive all the modules necessary to support Java SE 9 applications. Let's follow the same steps as we did previously for Java SE on the module java.se.ee module, and let's have a look at the graph. This is another aggregator modules. Right click, diagrams, show diagrams, Java modules diagrams. This is more complex, and let's make a little more bigger. Okay, Java.se.ee is an aggregator module which include everything in Java SE module and additional Java SE modules with packages that overlap with Java EE Enterprise Edition platform. You will note there are some modules has a stripe line through them, like java.se.ee, java.xml.ws, java.xml.ws.annotations, and Corba and the other modules. Why this? This is because they are deprecated and is marked for removal in the future releases. Now, let's consider some problems that will face you when you design your module and how Java compiler will protect and inform you about such problems in early compilation phases, not at runtime. Let's close this diagrams. So, to avoid module graphs with a cycle, a module is not allowed to directly or indirectly reference itself. Doing so will result in a cycle when computing the module's dependency graph, and the compilation error occurs if a module graph contains a cycle. So, let us consider two scenarios here to avoid these problems, which are a module that incorrectly requires itself, and the second scenario is two modules that incorrectly require one another. So, to get more insights, let's see this with examples in our project. Let's get back to our IntelliJ idea. I have developed the two concepts under my cycle. For the first implementation, a module that incorrectly requires itself, open my.module, and here is a module dependency graph for this. Consider this declaration in which module requires itself. When you compile this declaration, or just it's give you a compilation error, the following error indicate a cycling of the module dependency, which is this dependency cycle on itself. To solve this problem, just comment this line and the errors will disappear. Let's consider the second problem. Open cycle, and we have developed two modules here, and each module have packages. No problem. Let's see the declaration for the first module, which is exports the package1 types and require my.cycle.module2. And let's open module 2 and open its module-info declaration, and you will see that it's require my.cycle.module1. So here is dependency problem, and this is contains the two modules and each one require one another. The compiler again will issue an error if you try to compile such an implementation as a dependency module between the both of them. So there is no way to reference one module from another one. So if you hover over this and see the error, here is a cyclic dependencies. My.cycle.module1 depends on my.cycle.module2, and my.cycle.module2 depends on module1. So to solve this problem, you have to comment one of the two requires. If you do this here, the problem will disappear. At the same time, if you do this from here, from module 1, the problem will disappear because only one required for another module. There is no cycles. I hope this make it clear. Ultimately, all the modules in the cycle are really one module, not separate modules. While recording this video, a friend of mine who works for a large organization told me that his team are preparing for Java 9 modularity migration. He indicated that they have multiple large pre-Java 9 jar files. Initially, they thought they would make each jar a separate module, but their jars turned out to be so interdependent that they have decided to combine them into a single module. This kind of interdependency is what leads to cycles in your design. Ideally, when you modularize a previously monolithic system, you want to break the system into separate modules that are easier to maintain and secure. But for sure, this can cause a significant refactoring challenges in large code base. So far, we have continued and our discussion of the module's dependency graph and all the errors could occur due to incorrect implementation ways of the module design.